Hey guys, welcome to Unit 3B, Section 5. This is the last lesson for Unit 3B, and this is talking about inequalities in triangles. We're going to recognize a lot of the same ideas because these inequalities actually are an extension of the hinge theorem. So what we're going to do is we have this triangle here. Now you don't have to draw this because you already have it. It says draw an obtuse scalene triangle. So one angle has to be greater than 100 or 90 degrees. And then scalene means all the sides are different. So if we were to list this out, let's go ahead and just mark 1, 2, 3, just to show that it's 3 different sides. Now, if we're looking at the angles, we are going to go based off of our drawing here. It looks to be that if we're going to order these from smallest to largest, angle C is the smallest, and then we have angle A, and lastly, angle B is the largest. Now, if we look at the sides, it looks like AB is the smallest side. This one over here. Next smallest appears to be BC. This one here. And then lastly, we have AC is the largest side. Now take note, look at the angles that are across from their corresponding sides in this list. So across from angle C, we have angle AB. Angle C was the smallest angle, and it was across from the smallest side. Okay. Then we look at angle A, which was the second smallest side, also across from the second smallest side. And as you can probably guess for the third one, angle B was the largest angle, and it's across from the largest side. So it does have a correlation between the larger the angle, the larger the side, which is what we talked about in the hinge theorem. So here's a couple theorems. Like I said, these are just extensions of that hinge theorem. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. It's like a fancy way of saying the bigger the side, the bigger the angle. The smaller the side, the smaller the angle. Here we have AB is greater than BC, meaning larger. So the measure of angle C, which is across from the big side, right there, has to be greater than angle A, which is across from the small side. Then we have the converse of this. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this is just the reverse idea, where 50 is bigger than 30, 50 is across from BC, and 30 is across from AB. Since BC is with the bigger angle, it has to be the bigger side. All right, so let's actually look at these, see if we can come up with some conclusions to write an inequality. Write an inequality comparing ST and RS. So here's ST, is this side over here, and then we got RS over here. We're trying to decide which of the two is bigger. Well, now we need to look at the angles because we can't tell visually. They look almost identical. Notice that the angles opposite of those sides are 29 and 30. Since 30 is bigger, look for the side that is across from it, which would be RS. RS has to be greater than the side opposite of the 29, which is ST. The next one, compare the measures of angles L and N. So L and N, we don't know what their values are, so we want to look at the sides then. So the side across from L would be NM, which has a value of 6. And then the value across from N is 5. Since 6 is bigger than 5, we know that angle L, which goes with 6, has to be greater than angle N. All right, so we're just matching up angles with sides. Okay, there's one more theorem. This is called the triangle inequality theorem. It states that the sum of any two sides of a triangle is greater than the length of the third side. So the two short sides, basically this is the idea. The two smallest sides have to add up to be bigger than the third side. Otherwise, you're not going to be able to construct a triangle. So is it possible to construct a triangle with these sides? Technically, we were supposed to do 3 different inequalities. So here's our 3 sides, 4, 5, and 6. And if we do this 3 times, let's take one combination of 2 sides, which would be 4 plus 5. That is technically bigger than 6. So that's true, because 4 plus 5 is 9. Then we could do 4 plus 6 has to be bigger than 5. So if we use this one, that is also true, because then we would get 10 is greater than 5. Lastly, we would use 5 and 6. Those are the other 2 values. Those have to be greater than 4. It's just rewriting the sides in different combinations, but every single time it's true. Now, the only one that really mattered was this first one. As long as the first one, where you compare the 2 smallest sides bigger than the third, it'll always work. All right, so let's look at B. If you look at B, if we start out with the first 2 sides, 2 plus 3 in comparison to 6, 2 plus 3 is not greater than 6. That is false. If you think of it, that's like trying to construct a triangle where if this side is 2 and this side is 3, make it a little longer, our third side, to get it to be exactly 6, it would actually be too long. We wouldn't be able to reach the other endpoint right here. So that's where this triangle inequality theorem comes into play. So it's actually not possible to construct. So this one is a yes, and this one is a no. The 2 small sides are not added together to be greater than the third side. Okay, now we're not actually going to do the spaghetti extension, but the idea behind it we are going to use. If a triangle has sides described below, with sides AB being 6 and BC being 13. So let's draw a triangle ABC. We really don't know much about the triangle other than the fact that 6 and 13 are 2 of the sides. Let's just say it's like this. We don't know whether 13 is the biggest side. We don't know if 6 is the smallest side. So we have to think about the different possibilities and combinations that we could use in order to construct a triangle that's possible. All right? So let's assume that 6 is the smallest side and that 13 is the biggest side. So we would say that 6 plus x has to be greater than 13. Then we could also assume that 6 and 13 are the small and medium sides, and x is the biggest side. Or we could have a combination. Well, actually, these are the only 2 that matter, because 6, since it's smaller than 13, it's obvious that 13 plus x has to be bigger than 6. This one's just true. Regardless, we can figure that one out intuitively. Because you can't have a negative side, we wouldn't have a negative value for x. So these are the 2 that matter. What we're going to do is let's solve for these 2 inequalities and then put them together. So 6 plus x is greater than 13. What we would do to solve for x is just subtract 6. X has to be greater than 7. Or, let me change my color here so we can see it. 6 plus 13 has to be greater than x, which is 19. Now, if we were going to combine these 2 ideas here with this one right here, x being greater than 7 and being less than 19, that's a 2-part inequality. How we write that is like this. Sorry, I keep changing back and forth. You put x in the middle. You know that 19 is the biggest number possible, and you know that 7 is the smallest number possible. So x has to be greater than 7, but smaller than 19. So this is how we can write it. You can also write it the reverse order. 19 is greater than x, which is greater than 7, but you need to make sure you change the signs and change your numbers in that position. The shortcut to this that we could have done to figure out 19 and 7 is just add the 2 numbers together. 6 and 13 makes 19, or subtract them. 13 minus 6 is 7, and then we can always set up our inequality like this. We'll do some more practice with this together in class, but remember that you are doing the workbook problems for Unit 3B after you're done with this video. That is your homework for these